Year 8, good day once again. We're looking at the second lesson on volume and capacity. Today, our intention again will be to solve volume and capacity problems. We'll apply FSSU framework to solve these problems, and that will be our success criteria. And also, the first lesson we did will be a constant reminder of the skills we need to apply. Thank you very much. Let's have a look at today's problem. First one. The capacity of a container with side lengths 10 centimeters can be found by first calculating the volume. So to find the capacity, you need to find the volume. And we already know that the volume is L times W times H, the length times the width times the height. So with the FSSU, once you've written down the formula, you do the substitution. In this case, it will be 10 by 10 by 10, and we simplify, and that's the units. There we go. So 10 by 10 by 10, that's 1,000 cm cube. Now we need to change the cm cube to milliliters, and the conversion factor is simply 1,000 cm cube is simply equal to 1,000 milliliters. So 1,000 cm cube is equivalent to 1 liter. One thousand cm cube equals 1 liter. So basically 1 cm cube or 1 cubic centimeter is equal to 1 milliliter. Right. So keep this in mind, and we'll apply that when we have to solve other problems. We'll return to unit conversions later on in this lesson as well. Right, so we want to calculate the volume of this cylinder and determine its capacity. Well, so what have we been given? We know that the height h is equal to 15 centimeters. We know that the radius r is equal to 3 centimeters. These are the things which are given. And we know that the area, cross-sectional area, is a circle, and so that will be pi r squared. So again, we start with the volume formula, which is F, and then we do the substitution, and we simplify and units. Let's remember to apply these principles. Okay, so the area is that of a circle. So that's pi r squared multiplied by h. Our r is 3 centimeters. So we substitute that. H is 15 centimeters. We substitute that there. You perform this calculation using your calculator. Let's confirm that. So we have pi multiplied by 9 multiplied by 15, and that gives us 424.115, and so on. Now to 2 decimal places, remember that's a 5, so we add 1 to this 1 here to make it 2, and that's why we have that answer given to 2 decimal places. So this is what we saw on the calculator. That's what we saw there, and then you round to get that. Now, we know that the volume equals or approximately equal to 424.12 cubic centimeters. Knowing very well that 1 cubic centimeter is equal to 1 milliliter, it's just a matter of replacing the units basically. So instead of cm cube, we will have milliliters. That's our final answer because the units are basically the same, the cubic centimeters and the milliliter. How much liquid can this container hold? Again, we have to work out the volume, which is length times width times height. What do we know? We know that this looks a bit suspicious. The way it is drawn is not drawn to scale. L equals 10 centimeters. W equals 10 centimeters. And H equals 8 centimeters. So let's pop that in. So 10 multiplied by 10 multiplied by 8. 10 times 10 is 100, by 8 is 800. And because they were all in centimeters, our unit is cubic centimeters. But we do know that 1 cubic centimeter equals 1 milliliter. So basically, the volume, the capacity is 800 milliliters. So this is how much liquid this container can hold, 800 milliliters. How much liquid can this container hold? Again, you need to work out the volume first. The cross-sectional area has been given as 32 square centimeters. So A is 32 square centimeters. Let's pop that there. Remember, that's our formula. Substitution will simplify, get our final answer. The height H is equal to 15 centimeters. So we pop the H there, and we need to perform 32 multiplied by 15, and that gives us 480. So we have 480 cubic centimeters, knowing very well that 1 cubic centimeter is equal to 1 milliliter, then that capacity is simply 480 milliliters. Easy done. What about this fish tank? The capacity of this fish tank in milliliters rounded to 2 decimal places. Let's keep all that in mind. So what do we know given? Let's write it down. Given was given to us. Well, we know the radius equals 14 centimeters. And we know the height h is equal to 20 centimeters. So the area of this fish tank is circular. So the cross-sectional area is giving us pi r squared because it's a circle. Now, because r is 14, we have pi times 14 squared multiplied by 20. So basically, we can grab our calculator and do some calculations here. So 14 squared multiplied by pi, that gives us, let me just write it here from the calculator, it gives me 615 0.752, and so on. Now, because we're going to do 2 decimal places, it's really not useful to round here before I multiply by the 20. So I'll skip this step and multiply that answer by 20. If I multiply that answer by 20, I get 12315. That's 12,315.04, and so on. There's a point here. All right. Now, 0.04, let me put the 3 and so on. Because it says 2 decimal places, this is my second decimal place, the 4. So that's a 3, so I don't need that. So this is 12,315.04 to 2 decimal places. Now, because 1 cm cube is equal to 1 milliliter, the final answer is simply 12,315.04. I'm having trouble doing the 0.04. So that is our capacity of the fish tank, which is about 12.315 liters. Okay. Convert the following measurements. So you have a jar, which is 300 milliliters. So from you have 1,000 milliliters will be equal to 1 liter. So if you have 300 milliliters, then how much would that be? Well, of course, it will be less than a liter. So you divide. So it will be 300 divided by 1,000, and that will be in liters. So that's precisely the calculation we do here. And because we're dividing by 1,000, you just move the decimal point 1, 2, 3 places. So that gives you 0.3. Don't need a calculator for that. 0.3 liters. 750 mils, again the same argument. If 1,000 milliliters will give you 1 liter, then 750 milliliters will give you less than 1. So you have to divide that 750 by the 1,000. See the argument? To get it in liters. And again, we're dividing by 1,000, so that's 0.75. There's a 0 at the end, but it's redundant. We don't need that, so 0.75. Right. Now, these basic home items, sometimes they are bigger than a liter. So this is 1.25 liters, and we want it in that. You can have the same argument we had before. That is, 1 liter gives you 1,000 milliliters. So if I have 1.25 liters, then of course I'm going to get more of the milliliters. So because I'm going to get more of it, I have to multiply, so it will be 1.25 multiplied by 1000. And that will give me in milliliters. And if I do that, that gives me, I'm multiplying by 1000, so I just move the decimal point 3 places to the right. So that becomes 1250 milliliters. 1250. So 1250. We'll get more of that. Can do the same argument for an orange juice, which is 3.2 liters. So it will be 3.2 multiplied by 1000. So you can see when it is given the bigger unit and you want it in the smaller units, like moving from dollars to cents. Basically, a dollar will give you 100 cents. How do you know that? Because 100 cents equals $1. So if I have a dollar, I multiply by 1 by 100 to get 100 cents. If I have $2, I multiply by 100 to get 200 cents. So 3.2 liters multiplied by 1000, and that gives you 3,200 milliliters. You just move the decimal point 3 places to the right. You don't need a calculator for that. Cheers. So now let's focus more on unit conversions for a moment, because already we do know that 1 cubic centimeters equals 1 milliliter. So that means 1,000 cubic centimeters, which is equal to 1,000 milliliters, is also equal to 1 liter. Right. Now let's try and find some relationship between the meter cube and the kiloliters in relation to these things here, from what we know. Now, let's suppose I have a cube. Let's suppose I have a cube. Each of side a cube, which is of side 1 meter by 1 meter by 1 meter. Then we know that volume is simply L times W times H. So that will be 1 meter times 1 meter times 1 meter. That volume will be equal to 1. Because it doesn't matter how many times 1 multiply itself, it's still 1. So 1 cubic meters. Now, if this 1 meter we know is 100 centimeters, 100 centimeters, and 100 centimeters. So the same volume, which is 1 meter by 1 meter by 1 meter, in terms of centimeters, it is 100 centimeters by 100 centimeters by 100 centimeters, which is equal to 100 by 100 by 100. That's a million, which I can write it. Let me just write it as 1,000 by 1,000. It's 10 to the power 6, but I'll just write it as 1,000 by 1,000 for the time being. Cubic centimeters. As I said, this is equal to 10 to the power 6 cubic centimeters. But I'll write it this way. By writing it this way, you can see what I'm getting at. So this volume is the same as 1000. This volume is the same as 1000 times, now 1000 cm cube is the same as 1000 milliliters, and it is the same as 1 liter. So this is 1000 liters, and 1000 liters is equal to, the 1000 is kilo, so kiloliters. So basically what I've just done now is telling you one cubic meter is equal to 10 to the power of 6 cubic centimeters. That's the first one I showed, but I've also shown 1 cubic meter is equal to 1, let's put a 1 in front here because that's still a 1 kiloliter, 1 kiloliter. And this is very important. So 1 cubic meter is equal to 1 kiloliter, or 1 cubic meter equals 1000 liters. That is this point here. So this is a powerful way we can work out. It's a powerful way we can work out volume units. So we'll make use of this in our next question. So we got a swimming pool, and the length equals 6 meters, the width equals 4 meters, and the height equals 1.5 meters. Okay, so what we want to do is we want the capacity. These are the dimensions. We want how many liters of water would need to fill it, the swimming pool here. So that's the formula given. So let's pop in, substitute our values. So 6 times 4 times 1.5. And what is that equal to? 6 times 4 is 24 times 1.5. That will give us 36. So 36 cubic meters, because they are all in meters. Right. And what do we know? We do know that 1 cubic meter is equal to 1 kiloliter. So 36 cubic meters, 36 cubic meters is simply 36 kiloliters. So this will be 36 here, kiloliters. Now we want liters. So all that we need to do is to multiply by 1000. So 36,000 liters is what is needed to fill that swimming pool. 36,000 liters needed to fill that pool. Right. Oil is usually measured in barrels. barrels per day. That's how much the oil output is given. So we got an oil barrel here. And the question is, what is the capacity of this oil drum to the nearest liter? To the nearest liter. So what we need to do here is we need to write down the things that we know, which is given to us, given in the problem, because we have to calculate the volume first. We know the diameter to be 17 centimeters. So if the diameter is 17 centimeters, then the radius is just half of the diameter, and 17 divided by 2, that gives us 8.5 or 8.5. What is the height? That's the height of our drum, which is 22. So H, let's write it here, H equals 22 centimeters. So everything is in centimeters here. Now, because the drum has got a circular cross-sectional area, we are going to use V equals A times H, where our A is pi r squared, because that's the area of a circle, and multiply that by H to give us the volume. So pi times 8.5 squared multiplied by 22. So we need to grab our calculators, and we're doing this to the nearest liter. Remember, our answer will be in milliliters. So really, the decimal points have no value here, because we're still going to be dividing by 1,000 to get into liters. So let's grab our calculator and do second function times 10. That gives you the pi on this calculator. Multiply that by 8.5 squared, and we multiply that by 22, and that gives us, so I'll skip this part here, and I'll just put in what I have on the calculator, because I do it in one step, and that gives me 4,993 point other things. But because this is in cubic centimeters and we're going to divide by 1,000, all those decimal points are irrelevant. Okay. Now, I probably need to do that. I'll probably pop in those two there, but it's irrelevant. We'll see in the end. Now, in milliliters, it will be the same value here, 4,993. As I said, these decimal point things are really irrelevant, because we're dividing by 1,000. And then in liters, we need to divide the 4,993 by 1,000. And if you're dividing by 1,000, the decimal point is just moving 1, 2, 3. 1, 2, 3. So you got 4.993 liters. Okay, but the question says to the nearest liter. So to the nearest liter, we have to round. This is That's a 4. That's a 9. So I have to add 1 to the 4. So to the nearest liter, that will be 5 liters. So our final answer is 5 liters. So you see what we've done. All those decimal points at this point here were irrelevant because we are working to the nearest liter. So after dividing by 100, you need to do the rounding to the nearest whole number. That's to the nearest liter. And so that's 5 liters. Thank you very much. Right, the baffling box. So in this problem, you can see that this young lady is trying to make a gift box, but the trouble is he cannot remember the area. I mean, the trouble is she can remember the area of each face, but not the dimensions. That's her trouble. She can remember the area of each face, but she cannot remember the dimensions. Now, question 1. Based on the information given to you, you need to work out the dimensions. 2, you have to work out the volume of the proposed gift box. And 3, what is the total area of wood needed for all 6 of the box's faces? So you need to do that, you need to do that, and you need to do that. So please pause here, pause the video, copy the question in your book, and answer showing all the required working out. Make use of all the information we had in the previous lesson and today's lesson as well. Thank you very much. Right. So today our learning intention was to solve volume and capacity problems. We applied FSSU, which is the Formula Substitution Simplify Unit Framework, and we apply that to solve volume and capacity problems today. Additional work is just the problem I gave you on the baffling box. Please take your time, work through that. I've not provided the answers in this video because I want us to have a discussion on Google Classroom. So please, if you work it out, kindly give everybody the opportunity to do it first, and I will post and open the discussion. It may not be immediately after this lesson, but if you want to do it immediately after today's lesson, after you've watched the video, that's fine. We can open up the discussion. Otherwise, I can send another post to open the discussion, and then we can discuss so that everybody have had the opportunity to work through it. Right. Additional work. Additional homework will be on education perfect. Education perfect. And of course, you can also subscribe to my channel, Tabi Maths, for videos that I will upload on YouTube. Thank you very much, and keep working hard. Lovely guys. Thanks. Bye.